Greetings of the day, my dear students. This is Umar, teacher of mathematics. You are watching my YouTube channel, Maths with Umar. So today we are going to see Grade 10, Chapter 3, pair of linear equations in two variables. This is the first session of this chapter, and in this session, we are going to see two things. One, the behavior of linear pair of linear equations and the existence of solutions. So before going to that in detail, just let me recall the concepts of these two, how pair of linear equations behave. Let me share. Yes. So now in pair of linear equations, as you know, what are linear equations? Equations having degree 1 are called as linear equations. For example, 2x plus 3 equal to 5. It's an example of linear equations in one variable, because here we have only one variable. So why these equations are called as linear? Equations having degree 1 are called as linear equations because when we represent these equations graphically, they are represented as a straight line. Okay, so that's why these equations with degree 1 are called as linear equations. Now in this chapter, what we are going to see, linear equations in two variables. So tell me an example. Yes, 7x minus 5y equals 2, or you can also call it as 2m plus 3n minus 5 is equal to 0. So these are the examples of linear equations in two variables. Now, what does the chapter name suggest? So here in this chapter, we are going to see how a pair of linear equations behave when they are together, how they behave, and what can be the solutions, or how, whether the solutions exist or not. This we are going to discuss in this chapter, and moreover we are going to see how can we use this concept in solving daily life problems. Okay, so the first thing, the behavior of linear equations, pair of linear equations. Okay, that is the main thing we are going to see. And the next one, what we are going to see, existence of solution for this linear equations. And the third one, applications. Okay, and before going to the third one, we are going to see how to find the solutions for the given pair of linear equations. Okay, so in this lesson, let us see the main thing, behavior of linear equations, and in finding the solutions. Let us see the first method of solutions, which is nothing but terminating method. So terminating method, today we are going to see these two concepts in pair of linear equations in two variables. Yes, we know that the standard form of linear equation, linear equation in two variables is ax plus by plus c equals 0. See, in place of x and y, you can also use anything, but in this chapter, let us use x and y as the variables. Okay, and where a and b are the coefficients of x and y respectively, and c is a constant. Okay, so when we talk about a pair of linear equations, my dear students, pair of linear equations, the first equation will be a1x plus b1y plus C1 is equal to 0, and A to X plus B to Y plus C2 is the second linear equation. Now, when two equations have been given, how they behave? So, what are the three situations we can find out? See, let me explain you, my dear students. When we have two equations, so linear equations, either they intersect at one point, or the two equations can be parallel, or the thing theoretically, the third one is equation can coincide, or it can be one above the other. Okay, so there are three situations. The first situation is called as when two lines are intersecting, those two lines are called as intersecting lines. So that means they intersect at one point. And if two lines doesn't intersect, those are called as parallel lines, lines which are parallel to each other. And the lines which fall one above the other, they are called as coincident lines. So that means when we take two linear equations, so these are the situations. What is the first one? Intersecting lines, and the second one parallel lines, and the third one is coincident lines. Now let us see the relation or the condition in these three situations. Okay, so let us go for that. So the first one, when we talk about coincident lines, coincident, when the two lines are coincident, what happened, my dear students? Since one line is above the other, so it is that the two lines are made up of same points. So that means the ratio of coefficients of x is equal to coefficients or ratio of coefficients of y is also equal to ratio of constants. That means the two equations are equal. And let us go to the next one. What is the next one, my dear students? The next one is that if two lines are parallel, if two lines are parallel, we know that everything, the coefficients of x and y will be the same. Only the thing which differs is the constants. So what is the condition over here? A1 by A2 is equal to B1 by B2, which is not equal to C1 by C2. So this is the condition. And what is the last condition which is left out? It is coincident lines. So sorry, coincident lines is over. So what is the what is the last one? It is intersecting lines. When two lines are intersecting, the coefficients of x and coefficients of y, the ratio of coefficients of x and ratio of coefficients of y are different. Why? Simply simple, the orientation of the lines are different, so therefore the ratio will also be not equal. A1 by A2 is not equal to B1 by B2. So before going to solve questions based on this, you should be very good in this concepts. So now let us see how they ask problems based on this concept in board examinations. For what value of P will the following pair of linear equations have infinitely many solutions? Yes, my dear students, we have infinitely many solutions. In which situation we have infinitely many solutions? When the two lines are coincident. So when the two lines are coincident, that means on the same line. So what is the condition? So the condition for coincident lines is A1 by A2 equals B1 by B2 equals C1 by C2. Is it right? So let us here, if we take this as first equation and second equation, what is A1? A1 is P minus 3 and B1 is 3 and C1, since the constant has to be brought to left hand side, it will be minus P. So now let us go for A2. What is A2? It is P, and B2 it is also P, and C2 it is minus 12. So for that, so what is according to the condition? P minus 3 by P equals 3 by P equals minus P divided by minus 12. So now you can equate these two things. When we equate, what happens? P and P gets cancelled. P and P gets cancelled. So P minus 3 equals P. Sorry, P minus 3 equals 3. So when you transpose minus 3 to the other side, right hand side, so P equals 3 plus 3, that is equal to 6. So therefore P is equal to 6. I hope you understand. So let us go to the next one. Find the value of k so that these two lines will be parallel. So when the two lines are parallel, what is the condition? A1 by A2 equals B1 by B2, but it is not equal to the ratio of constants. Is it right? So let us go here. A1 is equal to 4, B1 is equal to minus k, and C1 is equal to, if we transpose it to the left hand side, it will be minus 10. Then A2 equals 12 and B2 equals minus 9 and C2 equals minus 20. So let us go. Let us write the condition. 4 by 12 equals minus k divided by minus 9 is not equal to minus 10 divided by minus 20. So if we equate this, so what happens? 4 ones 4 ones 4, 4 3 is 12. So 1 by 3 equals, minus and minus gets cancelled, k divided by 9. Transpose this 9 to left hand side, it comes to numerator. So 9 by 3 equals k, implies the value of k is equal to 3 ones are 3, 3 threes are 9. So k equals 3. So students, let us go for the next problem. For what value of k, the pair of linear equations x plus y plus 1 is equal to 0 and 5x plus ky plus 10 is equal to 0 will have unique solutions? When we have one solution, my dear students, when the lines intersect each other at one point. So that means they are intersecting lines. So the lines are intersecting, the lines are intersecting lines. So for what is the condition for intersecting lines? A1 by A2 is not equal to B1 by B2. So that implies, now in the here A1 is equal to 1, B1 is equal to coefficient of y 1, C1 is equal to 1, and A2 equals 5. B2 equals coefficient of y, that is equal to k. C2 equals 10, but we need only A1, A1, A2, B1, B2. Simplest, let us substitute. A1 1 by 5 is not equal to B1 1 by k. Now let us transpose. Is it right? Let us transpose k to left hand side and 5 to here, or cross multiply. So k is not equal to 5. So k is not equal to 5. So that means k is a real number and it should not be equal to 5. So therefore k can take all values, k can take all values except 5. Got it? So now let us go. Find whether the following pair of linear equations is consistent or inconsistent. So my dear students, let us recall the concept. If the lines are intersecting, those lines are called as consistent. And if they are parallel, if they are parallel, they are called as inconsistent. And if they are coincident, so coincident, they are called as dependent, but they are also called as consistent. Okay, especially they are called as dependent as well as consistent. So that means if we have consistent, if they are called as consistent lines, then either they should be intersecting or coincident. Got it, my dear students? So in order to find whether they are consistent or not, let us write what let us note down what is a1, a2 and find out the ratios. So a1 is 2 and b1 is equal to coefficient of y 3, c1 is equal to -7 and a2 equals 8, b2 equals 12 and C2 equals -21. So now let us find out the ratios one by one. So what is A1 by B, A1 by A2? A1 is 2 and 2 by 8, that is equal to 1 by 4. So and let us find out what is the ratio of B1 and B2. So B1 and B2, it is 3 by 12, that is also equal to 1 by 4. And now let us find out the ratio of the constant C1 by C2, that equals -7 divided by -21, that is equal to minus and minus gets cancelled, it is 1 by 3. Here we can clearly see that A1 by A2 equals B1 by B2, which is not equal to C1 by C2, and we know that this condition satisfies for parallel lines. Okay, parallel lines. And we have already recalled that parallel lines are called as or inconsistent lines. Understood how to solve this? Let us go to the next one. Find whether the lines representing the following pair of linear equations intersect at one point, that means intersecting lines, or parallel lines or coincident lines. Let us see the same thing. Let us find out what is A1 here, 2, B1 equals 1, C1 equals 3. And let us go for the next one. A2 equals 4, B2 equals 2, and C2 equals 6. Let us find out the ratios. A1 by A2, it is 2 by 4, that equals 1 by 2. And let us see what is B1 by B2. B1 by B2 is 1 by 2. And C1 by C2. What is C1 by C2? It is 3 by 6, that equals 1 by 2. So we can clearly see that ratios of coefficients of x is equal to ratio of coefficients of y is equal to ratio of constants. So all these three ratios are equal, and this is the condition for which one? Coincident lines. And we have learned that coincident lines are called as dependent, and which are nothing but coincident lines. Yes, yes, which are nothing but coincident lines. Understood? And yes, and we have seen that. So the lines which intersect at one point, intersecting lines and coincident lines, they are called as consistent lines. Is it right? They can be called as consistent lines. So now let us go for the next one. Find whether the following pair of linear equations is consistent or inconsistent. It is the same. So let us write a1 is equal to 3, b1 is equal to 2, and c1 equals, since it is on right hand side, minus 8. Let us go. A2 equals 6, b2 equals minus 4, c2 equals minus 9. Now let us find out the ratios. A1 by A2 equals 3 by 6 equals 1 by 2. And let us see what is B1 by B2. B1 by B2 is equal to 2 by minus 4, that is equal to minus 1 by 2. And let us see the ratio of constants. So it is minus 8 divided by minus 9. So it will be 8 by 9. Let us see the first two things. A1 by A2 and B1 by B2 are not equal. Here clearly we can see that A1 by A2 is not equal to B1 by B2. This is the condition for intersecting lines, and intersecting lines are called as, or also called as, consistent. They are termed as consistent. Got it, my dear students? Let us quickly go to the next problem. On comparing the ratios of coefficients, find out whether the pair of equations is consistent or inconsistent. It's the same. This is the first equation and this is the second equation. So let us find out. A1 is equal to 1, B1 is equal to minus 2, and clearly C1 is equal to 0 because we doesn't have any constant. And A2 equals 3, B2 equals 4, and C2 equals minus 20. So let us find the ratio of the coefficients. A1 by A2 equals 1 by 3, and B1 by B2 equals minus 2 divided by 4. If I take out the common factors, it will be minus 1 by 2. And clearly we can see that A1 by A2 is not equal to B1 by B2. This is the condition for intersecting lines. And intersecting lines are termed as consistent. Got it, my dear students? So let us go to the next problem. Let us go to the next problem. Meena went to a bank to withdraw 2000. Okay, she withdrew how much? Rupees 2000. She asked the cashier to give her rupees 50 and 100 notes in denomination. Okay, fine. So Meena got 25 notes in all. So she got 25 notes. It is to be noted. Find how many notes of rupees 50 and rupees 100 she received. Okay. See, for example, 100 rupees. If you are taking 100 rupees, so you can take it as 10 notes of rupees 10, or 2 notes of rupees 50, or 1 note of 100 rupees, or even you can take it as 5 notes of 20, and so on. Understood, my dear students? So she wanted the cash rupees 2000 in the denomination of rupees 50 and rupees 100. Okay, fine. So now let us note down, what is important, what is being asked, how many notes, how many notes. So whatever he has asked, let number of notes of rupees 50 is equal to x, and number of notes of rupees 100 is equal to y. Is it right? So we know that total number of notes is equal to how much? Total number of notes. So total number of notes is equal to 25. It is already given, right? It is given. So that implies x plus y is equal to 25. So this will be the first equation. Now let us see, let us use the next concept, next one which he has given, that what is the total cash? 2000. Understood? Suppose for example, I will explain you. If you have 5 notes of 20 and 2 notes of 100 rupees. So what is the total? How many notes you have? You have 7 notes. And what is the amount you are having? See, 5 into 20, 100, 2 into 100, 200. So total how many rupees you have? You have 300. Got it? Understood, my dear? Now, what does the problem explain you? So they are telling that this 2000 rupees is in the denomination of 50 and x. So how many notes of 50 are there? X. So therefore, total value of notes is equal to rupees 2000. So this can be written as, you have x notes of 50, so the value will be 50x, plus you have y notes of rupees 100, so the value will be 100y, equals how much? 2000. So this will be the second equation. Now if I solve this second equation, so I can take 50 common. So if I take 50 common here, what will be there? 50. If I take common, x plus 2y equals 50 into 40. So on both sides 50 gets cancelled. That implies x plus 2y equals 40. This is the third equation. Now let us solve these two equations using terminating method. Okay. So what is the first equation? X plus y equals 25. And what is the third equation? X plus 2y equals 40. X plus 2y equals 40. So this is first equation and this is second equation. Now subtract second equation from first equation. And we have studied whenever we subtract, the sign changes. So here this plus becomes minus, here also plus becomes minus, and here also plus becomes minus. So what is x minus x? It becomes 0. Now y minus 2y, if you don't understand, you can write, you can use rough. Y minus 2y. What is y? 1y minus 2y? It is minus y. So minus y equals, here 25 minus 40. Everybody knows it is minus 15. So both sides you have minus, multiply with minus 1 on both sides, it becomes y is equal to 15. And once you get y is equal to 15, substitute y is equal to 15 in any equation. I will take first one. So x plus, let me do it, yes, x plus y equals 25. So implies x plus 15 equals 25. Implies x is equal to 25 minus 15, that is equal to 10. So what is that we got, my dear students? We got x is equal to 10 and y equals 15. So therefore number of notes of rupees 50 is equal to 10, and number of notes of rupees 100 equals 15. And In rough, you can even check. See, 50 rupees, how many notes? 10 notes. So it will be 500 plus 100 rupees notes, how many? 15. It will become 1500. So what is total, my dear? 2000 rupees. Understood? This is how we do the problem, and we apply the concept of pair of linear equations, and in that terminating method, solving two solutions in terminating method, we do like that. So let's move on to the next problem. Let us see what is the next problem. 4 chairs and 3 tables cost rupees 2100, and 5 chairs and 2 tables cost rupees 1750. He has given two different situations. Okay, find the cost of one chair and one table. See, you have to note, whenever any word problem has been, whenever you read any word problem, you note down what is given, and the next one what you are supposed to find out, and what is the concept. Okay, if you understand this, then apply the formulas or concept, you will get the answer. So now what is given here? The first, 4 chairs and 3 tables. Cost of 4 chairs and 3 tables is equal to 2500, 2100. And what is given? 5 chairs and 2 tables cost rupees 1750. Okay, these are the two different situations. Okay, fine. Then what you are supposed to find? Cost of one chair and cost of one table. Okay, let us go for solution. Whatever he is asking, let cost of one chair is equal to x, and cost of one table equals y. Now what is the situation, case 1? So the case 1, he has given cost of 4 chairs. Understood? Cost of 4 chairs and 3 tables equals 2100. So I will write it as 4x plus 3y equals 2100. Let it be first equation, and let us go for the next one. What is given? So cost of 5 chairs and 2 tables equals 1750. I will write it as 5x plus 2y equals 1750. Now let us solve these two equations. What is the first one? 4x plus 3y equals 2100. This is first equation. And what is second equation? 5x plus 2y equals 1750. This is second equation. See, in order to solve them using terminating method, what should be equal? The coefficients of either x should be equal, or the coefficients of y should be equal. Here we don't have. So what shall we do? It's simple. Do the LCM. That means multiply in order to equate the coefficients of x. Let us multiply the first equation with 5 and second equation with 4 and see what happens. When we multiply first equation with 5, 5 fours 20x plus 5 threes 15y, and 5 times 2000, it is 10,500. Okay, and let us multiply the second equation with 4. So this with the second equation with 4, 5 fours 20x plus 4 twos 8y equals 4 times 1000 is 4000, and 750 into 4 times it is 3000. So it is 7000. I hope, if I am not wrong. So now since the coefficients of x is equal, so but the signs are also equal, so therefore let us subtract now first equation minus second equation. Okay, So let us subtract. Whenever we subtract, sign changes for the each term of the second expression. So here this becomes minus and this also becomes minus and here also become minus. And 20x minus 20x gets cancelled. 15y, let us write in rough. 15y minus 8y equals 7y. Let us write here equals 10,500 minus 7,000. So it is equal to, I think it is 3,500. Okay, and that implies y equals 3,500 divided by 7, and we know that 7 fives are 35 and remaining 2 zeros. So therefore y equals 500. What is the next job, my dear students? Substitute y is equal to 500 in first equation. So 4x plus 3 into 500 equals 2100. So 4x implies plus 1500 equals 2100 implies 4x is equal to 2100 minus 1500 implies 4x equals, I think it is 600. Okay, so implies x is equal to 600 divided by 4, that is equal to, I think, 150. So you got x is equal to 150. Okay, we got x is equal to rupees 150 and y equals, I remember it as rupees 500. So what is x, my dear? I think cost of one chair. So therefore cost of one chair equals rupees 150 and cost of one table. What is cost of one table? It is rupees 500. Got it, my dear students? Inshallah. So today we have studied about two things. One is the behavior of pair of linear equations in three different situations, and the existence of solutions, and solving two pair of linear equations using elimination method. Okay, so what is that? The three situations are: the two lines may be intersecting, or the two lines may be parallel, or the two lines are coincident. Okay, so the first one intersecting and last one coincident are called as consistent pair of linear equations, and the parallel lines, that means which we don't have any solution, that is called as inconsistent pair of linear equations. Okay, then uh, what else we have? Yes, we have learned how to eliminate how to solve equations using elimination method. Is it right, my dear students? So let us meet tomorrow for the next session of pair of linear equations in two variables. Okay, so please like, share, subscribe so that others also can benefit from this video. And moreover, please let me know whether you have liked or you have any doubts in the concepts which we have gone through today. Okay, stay safe, stay healthy. Bye bye.